drive up to the top of Hamilton. Don't drive up to the top of Hamilton Hill and get stuck in the mud. But what we're looking at is an ideal view of the sky to the north with, all right. Now, if you're up at 2 or 3 in the morning, this is how it's going to look. Let's pretend it's a clock, and let's go clockwise backwards a little bit when you're in your little light. Yeah. Swing it this way a little bit. So the Big Dipper is going to be up here at 1 o'clock, let's say.
Like that?
No.
Oh.
Out of control.
Okay.
Just a little bit.
Okay. I can't move.
Okay. We don't have to move it. Pretend, though, that the Big Dipper is just over here a little bit. Okay. And that means the Little Dipper would be a little bit to the left and upright at 9 in the evening, more or less. But what I want you to do is, once you find the Big Dipper, which if you consider Polaris, where's Polaris? That's Polaris. If you consider that the center of a clock, then the Big Dipper at around 9 o'clock in the evening in the middle of March would be over roughly at 1 o'clock. And the Little Dipper would be more around like 7 or 8 o'clock. Okay, so we just swing it a little bit clockwise. Then what I want you to do, we all know how to find Polaris, right? You want to use your little marker. The end of the Dipper points to Polaris. And that, for us in 2000, is our pole star. However, let's go to the middle of the handle of the Big Dipper, where that famous double star, Mizar and Alcor is, and run a line straight down to the brightest star, which I think is really this one, not this. And halfway in between, in a fairly dark part of the sky, but you can still see it on a clear night, is a star called, I don't know, what do you call it? Thuban?
Thuban.
Thuban?
How do you spell it?
Thuban. Any of you who studied the pyramids knows that 5,000 years ago, that was the North Star because of precession. And we're not going to review precession. You have your notes, or you can look it up. But we have this 22,000 year roughly cycle. And where we are now in the cycle, Polaris is the North Star. But 5,000 years ago, it was this star, Thuban. So I thought you'd have fun looking it up and thinking about that. Alrighty, what was our next one?
Is it higher on the horizon other times of the year?
No, it goes in a circle like all those others go, counterclockwise around Polaris.
Okay.
Okay, now we're looking up our second sky image.
The winter triangle one?
Yeah, let's do the winter triangle one.
Which one did you want? The one with Orion?
Yes.
That one?
That one's good enough. Not perfect, but it's okay. So once again, going back a year when we first started this program, one of the combinations of stars we looked at in our winter sky a year ago was Orion. You want to use your little, yeah, there we go. With its belt, Betelgeuse up at the top, and Rigel down at the bottom right. And then we found the winter triangle. But what I want you to do, though, really is check out, you can't miss it, Sirius, the brightest star in the northern hemisphere. And once again, if you have a good pair of binoculars and you find Sirius, which won't be hard to do, and place it at 12 o'clock in the circle that your binoculars make, just below 6 o'clock, you just have to shift your binoculars a teeny tiny bit. So you will find, right below Sirius, M41, a beautiful open cluster in the winter sky. So I thought we could, once again, check out Sirius and M41. And after we did that, We tried to find a larger span of the sky, but we couldn't quite do that. So we came up with a third one. Oh, that must be Kathy. Hi, Kathy.
Hello.
Hi. We are playing games here with the computer. All righty. What I had wanted to do was, if you were standing facing south at around 9 o'clock at night now, we couldn't get the whole thing. So Orion would be off to the right. So you want to run your little arrow off to the right, off the screen. Yeah. All righty. However, if you look east pretty much at 9, you're going to see the brightest star is Regulus in Leo the Lion, which is, they call it the sickle. I call it the backwards question mark. It's a very obvious asterism. And I want you to find Regulus off to the left. In other words, if you're looking south, turn left to your east and find Regulus. Then you're going to have to, up here, high in the sky, almost at the zenith, are the twins. And then a little bit higher off the screen and to the right, just a little bit, is your other bright star, Capella. So Regulus and Capella sort of bracket this part of the sky in March at 9 o'clock. And they're all easy to find. Capella is almost straight overhead and a little bit towards the west. And then the harder thing to find, but I think quite fun, and you can do it. Once you know where it is, you can see it with your naked eye if there's no moonshine and if it's a clear, dark night. Find Regulus down on the left. Find Castor and Pollux in particular, up on the right. And run a line between them. It's almost straight, slightly curved. And halfway between, in the middle of a somewhat dark part of the sky, is this constellation called Cancer, which is like an upside down Y. Can you? Yes, it's big and it's faint, and right smack in the middle of it, almost right smack on that line between Pollux and Regulus, is our wonderful beehive M44, which in ancient times they used that as the weather forecast. If you couldn't see it because it was too misty or hazy or a lot of humidity in the air, then they knew it was going to rain and probably storm. But if this atmosphere was dry, therefore clear, you could see it with your naked eye. So once you find it with the binoculars, you'll be able to spot it with your naked eye. Any questions about the homework for checking these things out, sort of like a review? Okay. Next part is we're going to look at everybody's images of their what they thought was the most beautiful. And we're going to start in the center of the solar system, which is not the Earth. Regina is here today, sitting over in the backside. We did away with that, in spite of what the church believed. The Earth was not the center. The sun was. So Melanie, you had to look up two things, right? The sun and Mercury?
The sun and Mercury.
Okay, so what did you find?
Okay. So I don't know if they're the most beautiful. Oh no, that's not mine. I took a photo. Yeah, now I have it. Sorry, technology. Okay, so this is my photo of the sun. This is from the 2017 eclipse. This was through a solar scope. So you can see this is the moon.
In the wings, I'm the backup.
Yeah. There's the moon as it starts across in front, and then you can see 3 solar spots. Those we learned last week were the darker areas.
Sunspots.
Sunspots. Yeah.
Okay.
And so it was really cool to be able to see those during the eclipse.
All right. So that was your sun shot. And
Yep.
then what did you do for Mercury?
Let's see what I did for Mercury. Oh. I did two different ones. I'm gonna go with this one. So these were the first images taken from the NASA Messenger mission. This was the first orbit around Mercury and the first images sent back from that orbit.
What year? Do you know what year that was?
Oh, I forgot.
What was the name of it?
Messenger.
Oh, I don't know either.
Was it 2003?
I don't know. I'm not good at that.
That's
okay.
It was fairly
a while.
recently.
Yeah. Okay. What is this? Is that a
crater?
A crater on Mercury.
Mhm.
Okay. All right. Who was Rima? She had Venus and Mars. So you want to find Rima's?
She sent two. This was.
Does she have it labeled?
This was her photo from Mars. You can see the cap, the ice cap.
Okay, there's the ice cap on, I'm going to say the South Pole, although sometimes, maybe Bob can explain this, telescopes sometimes reverse, so the top is the bottom and the left is the right, and they never tell you, and I kind of scowl and think, no, wait a minute, is that the South Pole or the North Pole? Well, I don't know, but it's one of the poles, and in the wintertime, because Mars is tipped on its axis like we are, so it has seasons. And so one pole will have the ice cap expand, and then it shrinks in the summertime. What's the dark? Do you think a dust storm? Rima?
I think those are just part of those, what they used to think were canals, but are just like craters and things.
No, it's way too wide. What's the dark? Is that a dust storm on Mars, the darker part? Looks like a bird. It's very wide. It's not narrow little lines. Your image of Mars. Rima's standing there thinking in the other room. She doesn't know. Okay, well, we'll move on. Then that was Mars. And then what was Venus? Going backwards now. We're turning the spaceship around and we're going back to Venus.
Well, she's looking at up that I use my smartphone, getting used to this thing. NASA Messenger was from August 3rd, 2004 to August 30th, 2015.
Okay. So somewhere in that time frame, that picture was taken of Mercury.
Yeah.
Okay.
And then there's Venus.
Okay. Once again, Rima, do you remember anything in particular about this particular shot of Venus? It looks like the atmosphere, but it's blotchy.
Oh, no, just that I liked it.
You liked it. Okay.
Yeah. Oh, I thought we were picking them out because they look pretty.
This is like the
I thought that
guys
was
asking
pretty.
about the car and you say, oh, it was blue.
Yeah, it was blue and it was big.
Big and blue.
It had 4
Okay.
tires.
Yep.
Yes.
Okay. So that's all. It's beautiful. Okay, once again, we take, with most of our cameras, if not all of our cameras, we simply take pictures of what our eyes would see in visible light. Remember that electromagnetic spectrum? Invisible light is a very narrow band, but in astronomy, you can use infrared or ultraviolet or X-rays or even sound waves. And so all different bands on the electromagnetic spectrum, and what you wind up with looks very different. The colors.
The other picture that I took of Venus is what it would look like if it had the water, like what they think it may have looked like millions of years ago when it may have had water on it. And I just thought that was really cool too. I thought, wow, isn't that interesting?
Now, did you hear Rima? Because she's in the other room.
Do you want me to pull that one
Yeah,
up?
we can hear her.
Oh, okay. She's going to pull up. Okay, once again, There is a theory there that once upon a time, Venus and the Earth were sister planets and had similar environments, weather, temperature, geology. But something went seriously wrong as far as human beings are concerned. I don't think Venus cares, but we would care. And some suggest that if we are not careful, we will wind up like Venus with the runaway global warming, because that's what happened on Venus. Runaway global warming.
Oh, really?
Mm-hmm. Maybe next winter, when we have time, we'll do a whole session on that. Okay, where's my list? We're up to, okay, Jordan, have you tuned in yet? Because you had the asteroid belt. Oops, he's still sleeping or something. Okay, Mary Lou, you're next with the gas giants, which would be Jupiter first and then Saturn.
Choose that.
Oh, wow.
You don't have a chance.
Mary Lou, are you there?
Yes, I am.
Okay, want to explain this amazing picture that you got?
Well, like Rima, I thought we were supposed to find one that we especially liked or was most interesting.
Yeah.
And I like this one because it has those four moons that we usually see way out there. They're all there in front of it. And there's the red spot.
That's really wonderful. So those are they the four Galilean moons, the big ones?
Yes.
Yes. All right.
And
Once
not only
again-
that, they're right there in the size.
Uh-huh.
I don't have nothing. I have no idea who took the picture, where it came from.
That's all right.
I just look for photos of Jupiter.
This would
and-
be like a merry-go-round where you'd have four rows of horses from the inside to the outside of the merry-go-round, but they're not all connected to the same floor. Each would be on a separate ring, and therefore each would go around the merry-go-round at a different speed, and therefore would pass a certain point differently. And every once in a while, all four of them wind up
They would
on the
line
same
up like-
side.
Yeah.
That one night when we were doing, we had Bob's bird scope in one of our star parties last year. And we actually got to see, I think it was it was all four of the moons. One was on one side and the other three were on the other side.
Right.
Yep.
Yep.
Okay. Of course, if this had been the lineup, we wouldn't have seen them at all with our little bird scope.
Yeah.
Yeah.
Right.
Okay, so that's we should give a prize for the best. Okay, that's Jupiter. What about Saturn?
I like Saturn's even better.
All right. Now, what do we,
There
what,
you go.
okay, there's Saturn.
Because I think that's Earth.
Mhm.
Really?
I think that's a picture of Saturn with Earth in the background.
I think,
You can
it's-
see Africa.
really?
Mhm.
No,
Yeah,
I think Earth's too small and too far away.
Well, I don't know, but that's what I found, and that's what I picked.
It could be
That
just showing
sure
the
looks like
scale
Earth to me.
Yeah, I think it's a Photoshop.
Yeah,
Right.
okay.
and showing
Oh,
the
It's
scale.
like-
Definitely
It's like
Photoshop.
the Russians photoshopping the war in Ukraine. Oops, it's not a war.
Yeah,
Right. And then, yeah, right. Okay, we won't go there. Yeah, I don't think that's the real thing.
okay, it's
No,
a
it's just-
Photoshop. But anyway, I thought it was interesting.
As Jordan, when he was 6, when Venus transited the sun, and we got up at 6 a.m. to see it. Afterwards, he asked me, he was only 6, and he said, Grandma, what if I was way out on a star? And then he paused and said, well, I know I couldn't really stand on a star, I would burn up. But if I didn't burn up, if I could stand on a star way out there and I looked back, what would the Earth look like? And I said, you wouldn't see it. We are too little and we don't make our own light. So that's why I don't think that's the Earth.
Okay.
Now, Mary Lou, do you remember a very cold February night many years ago when I had my new telescope and hadn't put it together? and you and Jerry and Clarence and his Margaret came to dinner. And as you four walked in the door together, Jerry looked down at the box and said,
Yeah.
"What's that?" And I said, "Oh, it's my new Celestron $800 telescope." And he said, "Why is it in the box?" And I said, "Because I didn't know how to put it together." He looked at Clarence and he said, "Well, dinner's not ready yet, right? We'll put it together." So he gets all the parts out, lays them out. He wasn't sure what to do either. But we called up Celestron on a Friday night at 5:30, and the owner was there in New York City. And he spent a half hour on the phone with Jerry, and they put the thing together. And so then we had dinner, and Margaret and you and I, Mary Lou, were talking happily together in the warm house. It was 10 degrees out. And the guys looked at us and said, "Well, aren't we going to go out and look through the telescope?" So we did. Anyway, later in the summer that year, do you remember, Mary Lou, there was a night, I think it was in the springtime, you could actually see all 5 planets, starting with Mercury in the trees to the west as the sun went down. And then I think it was Venus, but I'm not sure. And then it was Mars and Jupiter. And finally at 10 o'clock at night, Saturn. Do you remember looking through that fancy telescope and seeing the rings on Saturn?
Yeah.
It was so
That was amazing.
amazing, wasn't it?
Yes,
Way,
it
way,
was.
way, way out there.
Yeah.
Sort of a creamy yellow color.
Yeah.
Okay, who's next? Deb's not here, but she sent her information. She's getting their new car. You may not have heard. Well, we don't have to go there. Ice giants. She had the 2 ice giants. Ooh, that's a great one. Now, is that that's Uranus? Okay,
Yeah.
let's do Uranus first. Now, okay, guys, what's odd about this image of Uranus? What pops out at you right away that says, "Oh, that's strange"?
Well, the circles are going the wrong direction.
Yes, Uranus is that weird planet that's tipped almost totally on its side. And so instead of, sitting the way we normally see things, it's almost at a 90-degree angle. So all the moons, and it also has a band, what do we call it? Rings, but they're not nearly as many or as big or as wide. Okay. And it has
the aurora.
Okay, what's that white along? I'm guessing that once again, that must be some frost at the pole if it's wintertime. I'm not sure. Okay, that's Uranus. And then Neptune is the next one. And why we call these last 2 biggies gas giants is that, except for probably, we're not exactly sure yet, but most likely there's a small super dense core that's solid, but the majority of these 2 are gases.
Not necessarily, depends on the gas.
And I always think of Uranus as more of an aqua color, and Neptune much more of this deep, beautiful blue. And what we see, the white is, I think, nitrogen clouds, icy clouds, once again, whipping around in the upper atmosphere. Now, Neptune used to be our 8th planet, but now it's the last planet in the solar system because poor old Pluto got demoted. Alrighty, Bob, it's your turn with the KBOs. Kind of stuck you with, I don't know, are they beautiful?
Well, I think so.
Okay, what'd you find? And
I
what
mean,
are they?
one of them I think is spectacular. The one of Triton is interesting. The one of the pictures of our moon, I think, is really outstanding.
Okay, oh, wait a second. I'm sorry. Wait a minute, Bob. I switched, didn't I? Yes, I'm sorry. I switched you and Melissa because I wasn't sure if Melissa was back from DC yet. And I gave you our moon and Triton. So forget
That's
the
right.
KBOs for a minute. Sorry about
Okay.
that.
So I'm gonna I'll show this one.
No, it's just-
I'll try to show them all, Bob. We'll do this one first.
Yeah, there are two of, yes, that's,
Oh.
this one,
Oh.
you can actually read it down below, is a picture of a full moon taken from the International Space Station. And you see the curvature of the Earth, it's apparently done with a fairly big telescopic lens so that you're not getting much of the curvature of the Earth there. And what it reminded me of is that truly classic Earthrise picture taken by Apollo, the astronauts on Apollo 8,
Mhm.
that just has had a big impact on a lot of people. And this is the analogous picture taken from above the surface of the planet of the moon, whereas that one on Apollo 8 was a picture of the Earth taken from above the surface of the moon. I understand, just as an aside, when they took that picture of the moon, the Earth rise, every minute and every action was choreographed. And one of the astronauts said, "Give me the camera, there's this fantastic Earth rise." And another one said, "It's not in the guidelines. We're not supposed to do this." Fortunately, it must have been the commander that said, "Give me the camera." And they took that beautiful Earthrise picture that to this day, that was in 1968. And in fact, I think that was the one in which they were up there over the Christmas holiday. But that's what this reminded me of. I think it's a beautiful picture of the moon. Fairly simple. And then there's another one, the other picture of the moon, I think is just fabulous.
I used to use one of those in my art class when we talked about perspective, because 20 some years ago, the students were a little less knowledgeable than they over the years, and nobody realized it was the Earth rising and you were standing on the moon. Which, okay. Oh, wait, that one.
There.
Okay, what have we got?
Well, obviously you got a crescent, that's a waxing moon, isn't it?
Is it Venus? What's the date?
And the
No.
other image is Venus. In fact, if you look up, it says crescent and Venus.
Mm-hmm.
And
Oh, I
it's a
see it.
NASA
Tree line.
picture.
Mm-hmm.
Yeah.
What year was that taken?
2018.
Okay, because I was going to say a month ago in January, February, we had a similar lineup of a crescent moon, Mars and Venus, with Venus being the brightest it's been in quite a few years because of where it is in the sky in relationship to us and the sun. So yes, isn't that a beautiful?
And see, if you
sorry.
you bring it back.
Yep.
I see trees, don't I?
Yeah.
Yeah.
But if you look, and you don't have to look that carefully, you can actually see the whole moon.
Yeah.
Oh, right. Earthshine.
And Earthshine, that's some reflection from the Earth, and it's clearly a sphere. There's no question that the ancients had to notice that the moon was round and wonder about that.
Mhm.
And you can even tell that Venus is round.
Mhm.
So I just really like this picture. It's it's not a close-up of the moon or anything like that, or shows it's. I mean, this is just simply a very beautiful picture. Okay.
Okay.
And then there was Triton. And everything seemed to have been taken by a Voyager mission in 1989. The moon of
Neptune, right?
Neptune. And there are two pictures. This one was probably from a fair distance out. And I find it interesting when you look at it, the lower part is very rugged and then it seems to smooth out, but it's the upper part that you can see that's lit up is kind of dimpled in almost a regular fashion. Those have to be craters, but why are they dimpled in that way? And then, but on the right, it's, well, no, there's a fair amount of dimpling there too, but there are a lot more smooth areas. So it's quite, you quite see quite that change there. I don't know if possibly that's water or some other frozen substance. I didn't have time to look up what's known about Triton. I should do that.
It's nitrogen, isn't it?
It's nitrogen, Regina
be.
says.
Yeah.
Because you did some research on Triton
Yeah.
before.
And nitrogen eruptions spew nitrogen gas into the atmosphere.
Can you hear Regina from over there?
Yeah.
It orbits closer to Neptune than the Earth's moon orbits to our planet. Its surface has a pinkish hue and it's geologically rich and varied.
Right. It's quite a, maybe next winter we'll have a session on the weird O's in the solar system. And this probably would top the list because of all the large moons, it goes backwards in its orbit. It has a retrograde orbit, which means it cannot have been formed as part of the original solar system out of that disk of gas and dust. Most astronomers think it's a captured KBO, Kuiper Belt object.
Yeah, that's what I read.
Yeah, that's what you read, right?
Yeah.
And then it has a very elliptical orbit. Yeah. And there's actually, back in the day when we thought of Pluto as number 9, Pluto actually, because it had a really elliptical, still does, orbit, it would spend 20 of the whatever, rounded off 250 years that it took to go around. 20 of those years, I think 1970 to 1990, it was inside Neptune's orbit, which meant Triton also was, I think, inside one of the orbit of Pluto. No?
I don't know. I
Okay.
didn't read that.
I'll check my notes. But anyway, it's a very interesting because it's different. And once again, in science, I'm guessing the basic theories and theorems and laws all come from years or decades or centuries of observations, keeping records, making charts, and you come up with a pattern. But then something doesn't fit the pattern. So if you can figure that out, you learn a lot more about the system as a whole. So anyway.
There's at least 14 moons going around Neptune, but this is the only one that is spherical.
Because,
It was a captured object.
well, no, the reason why it's a sphere or odd shape is that I'm thinking, if I remember correctly, if you have a mass in our solar system and it's less than 600 miles in diameter, it will not form a sphere. It forms like the asteroids.
Oh, the size?
Large, yeah, it has to do with the size.
Oh,
So, but that's for next year when we talk about asteroids and KBOs and small moons. Yep. All right.
He had another one.
Now who's that?
Bob had another
Oh,
one.
Bob, you had another one? Okay, what did you have, Bob?
Well, it's actually fairly similar, but in fact, it has the details there showing the southern hemisphere. And I think this is that same area that we saw on the previous one that was so rugged. And this is a composite, taking various pictures and then overlapping them. Notice this one's actually colored, and the pinkish colored south polar cap is at the bottom. Unusual morphological features, including the long lineations at the center of the frame.
Yep.
And no one really knows details. Sometime maybe our issue several generations down we'll get there and further study.
What I had read, and I thought I think it's Triton. It has no atmosphere, but Regina, was that the one that had the geysers?
Yeah.
But it had geysers, or smoky.
It does have atmosphere.
A slight atmosphere, but the geysers, the smoky, dark, it looks like a charcoal smoky fire. They erupt and go pretty much straight up in the quote thin air, but then they hit the stratosphere, and there must be a wind up there because all of a sudden they turn right and they just go parallel to the ground. So, but we'll leave that for another time because
it has active geysers. It's volcanically active. It has a thin atmosphere, mainly made of nitrogen with small amounts of methane.
All right. Okay. Melissa didn't sign in. Did she send anything? No. Okay. What about Sandy? Did she send anything on comments? No. Okay, Kathy, it's up to you now with Io, a moon of Jupiter, and then Titan, the big moon of Saturn.
Okay. I sent over a couple pictures of each.
Alrighty. Let's do Io first. Yeah, there's Jupiter.
Yep. So this is Io, which I think this is not a photo.
No.
But I think what I remember the assignment, including Mom, was to have the most beautiful, which I think I interpreted as the most interesting. No one said I had to have a photo, so I do have a couple of renditions on mine. Anyway, so this one, so I think that, Io is very volcanic, right? And so I thought this picture or drawing really emphasized kind of what that might look like. And then I loved that it had Jupiter in the background.
And it's the closest of the 4 large Galilean moons to Jupiter, Io is, which is why it's so organic and not volcanic, all that stretch and pull. Okay, what's this one? This same, also Io?
The other thing is a picture. Yeah, these are just some different photo angles of it that I thought represented all the different color dynamics were really interesting. And then seeing it with just the shadow and almost like a crescent moon as well. It's interesting to see it in that kind of point of view.
Okay. And then our one that's exciting everybody these days.
I know, it's so exciting.
Titan. Oh, yeah. There may be life on Titan.
Yeah, there might be life. And then I think that what they said is like, I think it's 5 billion years from now, it could have life, like support life, like Earth would support life. So this, I think, actually is Saturn in the background, not Jupiter. So, but kind of again, an interesting kind of perspective when you're looking from space, kind of across the moon and off to another planet.
Okay. What's the bright, is that the sun?
I don't know what that is, but then I think the other thing that I noted on this planet or on this moon is that it's really pretty smooth. Like, I think that there are some craters here and there, but they think they're really young, in relatively, but it is a lot more smooth than Io.
Right, but it does have mountains. It does have huge lakes made of methane and ethane, and it has an atmosphere. I'm guessing, well, although it seems too large to be the sun. So once again, if it was a smaller bright light up there, shining through the haze of the upper atmosphere would be my guess. But it's too big at that distance to be the sun. So I
Yeah.
don't know.
Well, right. And I think, right, like it has that moon has 4 seasons.
Right, because once again,
Sure.
it's tilted axis.
Mhm. And then this last picture is really fun. So
Mm.
that's from the NASA Cassini spacecraft.
Mhm.
And again, just sort of like, it reminds me of the picture earlier of Neptune. It's just so smooth and pretty and beautiful.
All right. Okay, now we need to check on time. What time is it, Melanie?
Quarter up.
Quarter up.
Mhm.
Okay, Melanie has to go
Do you wanna
in
do
15 minutes.
To Regina's.
Okay, let's put my images up. Now, what I did was, I have this wonderful book that you have seen
Do you want
called,
to do Regina's?
oh,
The Meteorite.
wait a second. Did I forget Regina?
Mhm.
Oh, sorry. Somehow,
'Cause I've been talking.
you've been talking and I skipped you over. We have Regina to do with her meteors. Sorry.
I chose 2 different pictures of meteors. And the first one was, you tell me what it is.
Not the
That's supposed to be the oldest meteorite found on the Earth. It was found in Antarctica in 1984
Yeah.
by people that were searching for meteorites. And it's called the Allen Hills meteorite.
How big is it?
Oh, about the size of a baked potato.
Oh, it looks so much bigger. A baked potato. Okay.
It's similar to a rounded brick or a large potato,
All right.
formed from molten lava, and it weighs 4.75 pounds.
And how old do they think it is?
I didn't write that down.
Oh,
But
okay.
it's the oldest one they found so far on the Earth.
All right.
It's has gas traces that are found on, same gases are found on Mars, so they think it came from Mars.
Ah. Okay.
And then
And the other one was that diamond that was
Oh.
just recently sold,
Yep.
and it didn't get as much money as they predicted. That contains osbornite, a mineral found only in meteors. And I just thought it was interesting to show
Yes.
the
yes.
difference between the two.
And that's been cut by a jeweler to
Yeah.
facet it.
But you
Okay.
can see there's little bitty, like, it's porous.
Yeah.
You know, it's not real solid.
and there's like a
regular-
vein of something.
Yeah. It's not
Oh,
like a
right.
regular diamond.
How much did it sell for?
I can't remember,
Oh.
4 something million, but they
Oh.
thought it would get like 6 million or up, and it didn't go.
Just out of my
And
budget.
it also
Yeah,
was that cryptocurrency.
All right.
Okay, now.
Okay.
About 3,000 meteorites reach the Earth every year.
That we find.
Well,
Of course, the majority land in the ocean. We never find them hardly. Yeah. But it's true. Every year they go down to Antarctica, a team of scientists, and they get on snowmobiles and they spread out. It's like the police British movies where they're all crawling on the ground.